This section is 8.1.3, which is stretch factors of polynomials. By the end of this section, you should be able to create an equation for a polynomial function, either given a graph or given information. So looking at the first example, we just have a graph, and then it does say assume that a equals 1. So keep in mind, when we're looking at a graph, if this is all we have, you would always want to plug in a point to solve for a to identify the stretch factor. So in this particular graph, what we're going to do is find the x-intercepts. So we have an x-intercept at -2, 0. We have another one at 1, 0, and our last one is at 3, 0. Now looking at this graph, it looks like it is a third degree because it has 3 x-intercepts, and that also makes sense because it has 2 turning points. And the degree is always 1 more than the amount of turning points. And so from here, we're just going to convert this into factored form. So the equation, we can say it's p of x for polynomial of equation x equals, and we know a is 1, so it would be x plus 2, x minus 1, and x minus 3. Okay, looking at this next one, this one has a little bit more going on. So it looks like we have 1, 2, 3, 4 x-intercepts, but at 0, we also have a double root or double x-intercept. So this would actually be a 5th degree, which makes sense because it starts and ends in opposite directions. And then we do have 4 turning points, which would make it a 5th degree. The other thing that we can look at is that it's actually going downwards when you look at it from left to right. So we would have a negative in front. So first, let's identify the x-intercepts again. So we have -2, 0, 0, 0, but this one is a double root. We also have 2, 0, and 4, 0. Okay, so the equation will be p of x equals, and then you would want to put a negative sign. And then I'm going to go ahead and deal with the 0 first, just because I like the way that it looks better in the equation. So we'd have negative x squared, then x plus 2, x minus 2, x minus 4. Okay, and then when you look at that, that would be degree of 5. Okay, the last 2 examples are given information. So now we have a polynomial that has x-intercepts at 4, 0, -1, 0, 3, 0, and -2, 0, and then it gives us a point that it passes through. So in this one, we don't actually have a picture of a graph, just because I didn't, it's a little bit complicated to draw these to scale. So essentially what you should know is if you're asked to create an equation of a polynomial graph, you'd obviously first want to identify the x-intercepts and then put it in factored form. And then what you would do is pick a point on the polynomial and plug it in and solve it for a. So the only difference here is I gave you the point. Okay, so what we're going to do is go ahead and write this in factored form. So we would have y equals, we don't know a, but 4 would become x minus 4. -1 would be x plus 1. 3 would be x minus 3. And -2 would be x plus 2. So this is a 4th degree polynomial because it has 4 x-intercepts. So that would mean it would have 3 turning points. So we're going to go ahead and plug in 18 for y and 1 for x. So we plug in 1 everywhere we see an x, and then we're going to solve for a. So this process should look familiar because it's just like what we did with parabolas when we did the rocket project as well. So this would be 18 equals a, and then times -3 times 2 times -2 and times 3. So we get 18 equals, so this would turn into, we have -6 times -6, which would be 36a. So a equals 1 over 2. So our final equation would be p of x equals 1/2 times x minus 4 times x plus 1 times x minus 3 times x plus 2. So this is a fourth degree, and we have an a value of 1/2. Okay, and our last question here, we have a polynomial that has x-intercepts at 0, 0, -5, 0, and 1, 0, and it passes through the point -4, 60. So we're going to set it up in the same way we did the other one. So we would have y equals a, and then for our x-intercepts, we would have x, and then we would have x plus 5 to put it in factored form, and x minus 1. And then this is a third degree polynomial because we have 3 x-intercepts, which would mean it would have 2 turning points. And then we're going to go ahead and plug in the -60 for y, and then the -4 for x. So anywhere you see an x, you plug in that -4. And from now on, when you look at a polynomial and you're asked to find the equation, obviously you would find the x-intercepts, but again, you have to plug in a point in order to solve for a, unless it tells you assume a equals 1. Okay, so we would have -60 equals a, and then we have -4 times -4 plus 5, which is 1, and -4 minus 1, which would be -5. So we have -60 equals a times 20. So we have 20a. So a equals -3. So because it's an odd degree and it's negative, this polynomial would start up and end down. So our equation would be p of x equals -3 x times x plus 5 times x minus 1. So that is everything you need to know about creating an equation given a graph or information and learning how to find the stretch factor.